Welcome to Emerging Tech Horizons. I'm Dr. Mark Lewis. I'm the Executive Director of NDIA's Emerging Technologies Institute. And on today's show, we're going to be talking about blended wing body aircraft and more energy efficient aircraft options, particularly for the Department of Defense. And joining me for that conversation is Dr. Fay Collier, who is currently the Associate Director for Flight Strategy in the Integrated Aviation Systems Program at NASA. And I want to highlight that one of the fun parts about this conversation is, of course, Fay works at NASA, but he's also working with the Department of Defense. It's a great example of interagency cooperation and incredible support that NASA is providing for the Department of Defense. So I'm really looking forward to this conversation. Before becoming the Associate Director for Flight Strategy, Fay was the project manager of the Environmentally Responsible Aviation Project, part of the Aeronautics Research Mission Directorate at NASA. It's the first A in NASA, as those of us who love airplanes like to say. In that role, he directed the planning, execution of NASA's Integrated System Research Project, which really focused on the subsonic transport sector, included working in partnership with industry, the Federal Aviation Administration, the U.S. Air Force Research Laboratory, and some other government agencies. Fay's work includes development, integration of engine airframe technologies that would enable dramatic improvements in such things as noise, emissions, and overall performance characteristics for future subsonic aircraft operating in the air transportation system. And as the conversation evolves, I think you'll see the direct relevance to some of the DoD missions. By background, Fay is a graduate of Virginia Tech, PhD in 1988. He also went to that same technical institute up on the Charles River in Boston that I attended, MIT, where he got an MBA in 1997. And in that role, he was a NASA Sloan Fellow. Fay serves on numerous committees for NASA, including the JPDO's Environmental Working Group. He's on the Air Force Research Lab's Fixed Wing Executive Council. Again, great example of NASA Air Force cooperation. Has been a contributor on many national efforts, including we got to work together on the development of the National Research and Development Plan for Aeronautics that was spearheaded by OSTP a number of years ago and set this blueprint out for research that I think the country has actually paid pretty close attention to. It was a nice blueprint for where we needed to go and for the future of aeronautics. Fay is an advisor to works with many students across the country. He's very active in the American Institute of Aeronautics and Astronautics, an organization that I've spent a lot of time with as well. And so join me in welcoming Dr. Fay Collier to today's podcast.
Yeah, thank you, Mark. That was a kind introduction.
So Fay, I kind of want to start off. Tell us a little bit about blended wing body concepts. For our listeners may not be as familiar with the idea, and tell us what they are and what advantages they might have, particularly for the Department of Defense.
Yeah, thanks, Mark. Typically, we all travel, so we travel in what I call affectionately tube and wing airplanes, and we've been doing that for a long time. And what a blended wing body style aircraft will do is it'll take that fuselage that we sit in, and it'll blend it in a nice smooth way with the wings, providing a better lift distribution from tip to tip. So that has some other advantages as well. We're able to by blending the fuselage and the wings, we're able to reduce the overall wetted area of the configuration, and by reducing wetted area, of course, we reduce the drag of the airplane. So we have a nice bump and lift, and we have a nice reduction in drag, and that provides an efficiency gain for the aircraft itself compared to traditional tube and wing of about 15 to 30%, depending upon what you compare it to, of course. So older technology, bigger aerodynamic efficiency gain. Modern day technology, closer to like 15% aero gain. Back in the 80s, we're still flying aircraft, that were designed and built in the 80s. Maybe you might expect a 30% gain. So for the U.S. military and the DoD and the Air Force, we're looking at the blended wing body for potential missions out in the future. They could be tanker, they could be cargo, any number of missions where extended range, going further, burning less gas, delivering more payload would be needed.
Yeah, I guess for our listeners who aren't as familiar, of course, lift over drag ratio translates directly to range.
It
So
does, yes, yeah. You look at the Burgay range equation. I don't
yeah.
mean to get too technical here, but
No, that's okay. We got a
yeah,
technical audience. Yeah.
it has three factors, and L over D at cruise is one of the factors. And of course, if you can increase L over D at cruise, which blended wing body promises to do, you get a direct impact on range by the same amount or the same increase. Um, and so that's it's a powerful um, concept, and there's probably been 30 or 35 years of research that have gone into it, and so we think it's primed and ready for a large demonstration, and that's essentially what the DoD is interested in.
So tell us a little bit about the history, because of course there was the classic Northrop flying wing. The
Yes.
B-2 bomber is a flying wing. There was our mutual friend Bob Liebeck has done work on blended wing bodies for decades now. So
Yeah.
can you take us back? Tell us how the concept has evolved.
Well, I mean, that's a really important question, and to take it back to its origins, I go back to um, where I saw the first sketch of the blended wing body was in a memo capturing some lessons from an NRC exercise. The memo came from Douglas Aircraft. It was addressed to Langley Research Center, sketching out at that point in time items for thought to increase capability both on the commercial side as well as the military side. So in 1984, as I mentioned, we have our first sketch of the blended wing body, and that memo outlines some of the particular attributes that it might have for the military in particular at that time. Increased cargo capacity, more range, better offload. So these things were forecasted a very long time ago. And shortly thereafter, another friend of ours, Dennis Bushnell,
Hmm.
launched a working group to begin
Yeah,
to.
chief scientist at Langley, right?
Yeah,
Yeah,
exactly.
yeah.
Currently chief scientist in Langley. Um, when I met him, he was at the viscous flow branch. And in those days, we were studying a lot of concepts that had significant amounts of drag reduction. So Dennis launched a working group around this finding from the NRC. It was a pretty prestigious group. A lot of the giants in aerospace were involved in it, including Bob Liebeck. Bob and his colleagues at Douglas, McDonnell Douglas, picked up on this concept and started to do some paper studies on what it would look like, how much it might weigh, what the the Mach number should be. So they started doing the practical conceptual design pieces that we needed to start to quantify, some of the important parameters like, takeoff gross weight, the drag associated with the airplane. Noise characteristics were also considered. There were other concepts that it was compared to at the time. Dr. Finnegar's strut braced wing was looked at and was in the mix, and that group also evaluated that concept. And in the end, what they did is they assessed them, they ranked them, and in 1994, they recommended that we go forward with a research program around the blended wing body after doing all the puts and takes. And
So
of
yeah,
course, Mark, there's a whole lot more to say about what we did from there.
yeah.
And I can go on, but I'll let you interject if you wanted to
So no, no,
at
I was going to
points.
say I know you had you actually had an X plane to demonstrate the concept.
Well, yeah, I mean, there was a the X-48A, which came first as an X-plane, and some work was done there. I don't believe, if memory serves me correctly, we didn't get very far with that. It was a short-lived program. I believe funding shortages were a problem. But what happened with all of that work is we were able to identify some long poles associated with the blended wing body and what we needed to do to enable it, as a real airplane at some point in the future. Flight controls, low speed flight controls in particular, were of interest. That was identified as something we needed to continue to work on.
Hmm.
And then another major challenge was the flat-sided pressure vessel inherent in a blending of the fuselage and the wing. And so we needed a manufacturing concept, essentially, to efficiently handle a flat-sided pressure vessel, which is much more
Hmm.
difficult to do than a traditional tube-style fuselage. So those were two major programs that we embarked on in the 2004 timeframe,
Hmm.
along
Hmm.
with some high-speed wind tunnel testing of the configuration. So three focus areas that we took on.
So let's fast forward from 2004. And I know at the time in the even the 2007 2008 timeframe, there was a lot of discussion still about using blended wing bodies. We had at least one. We had a number of discussions about maybe the next Air Force cargo airplane should be a blended wing body. We the following to the C-5 or the C-17, and then that kind of went dormant, and now it's back.
Yes.
And so what is it that's gotten folks excited again about blended wing bodies?
Well, again, yeah, and that's a good way to put it because it's come and gone over the years in terms of excitement level. We had a fairly consistent stretch of research that I'll say extended from '94 to 2016 or so. A lot of times with technology like this that has an impact on fuel burn, the U.S. has been blessed with low gas prices for a very, very long time, and recently, that's changed. So gas and fuel, jet fuel is becoming more and more expensive. The other thing is climate has become more of a focus in the U.S., sort of catching up with a similar focus in Europe that's been going on longer. And so I think the sort of the combination of climate and carbon footprint focus and the cost of gas, frankly, has driven excitement in not only blended wing body but other technologies as well that have an impact on drag and can serve to reduce fuel burn and carbon footprint.
Yeah. So I know the U.S. Air Force, for example, an annual fuel bill that's the largest in the government. It's between $5 and $7 billion a year, which is just a staggering number. Um, I used to point
Yeah,
out it was a it's a lot. We spent a lot more money on jet fuel than we did say than on S&T, for example. Um,
and
so
imagine
yeah,
if you could suddenly wave a wand and reduce that by 20 or 30%.
right.
You
Yes,
know, and
absolutely.
you could divert those dollars to other things that are important as well.
Yeah, absolutely. Not to mention, bringing it back to some of the operational advantages. More range, more
Right. So
cargo for a tank of gas. Yeah.
yeah, right. So the range would be increased by quite a bit. The other advantage of the blended wing body is it's volumetrically efficient. And so for the same airplane, basically we can carry more stuff. And because it's more efficient, we can carry that stuff further. And, there's some debate about whether the airplane itself, the blended wing body itself, will weigh more or less than a conventional cargo carrier or tanker. But with the invention of the material system that we researched at NASA called, it's basically a stitched resin infusion technique. If you add that into the mix, which is an enabler for blended wing bodies, we feel like the airplane is not only as capable or more capable, but will also weigh less. And so it's an exciting combination of aerodynamics and structural efficiency that
And materials
and
and
materials that will enable missions that aren't available to commercial carriers as well as the military carriers.
right. So step back. As you know, I spent most of my career in the high Mach range, where
Yes.
we have some of the same challenges. Where it kind of goes through cycles of enthusiasm and being ignored, um, and then you always have the naysayers. So for blended wing bodies, what are some of the challenges, and what are some of the naysayers that you've had to you know to contend with?
Yeah, that's always there, as you know, and so I'm going to talk more about sort of some of the uh, uh, things I hear from a commercial passenger carrying perspective because that's where most of my focus has been. But people worry about the interior of the blended wing body and whether or not you'll have a window. Um, and this comes up every time I talk to somebody. I talk to a group. What about that? I won't have a window. It's like sitting in a cavern.
Because you're sitting in a large area. It's more of a stadium style. Might be more of a
Yeah,
stadium style. Yeah,
yeah. Width-wise,
yeah.
so basically, cabin mock-ups have been constructed, and people have been brought into those mock-ups. And there's some evidence to support the fact that once folks enter the cabin, find their seat, it's more like sitting in a living room than in a cramped space like we feel like sometimes in tube and wings. So it actually has advantages to cabin comfort that I think once people become familiar with it, they will agree that it's probably a better experience inside the cabin than it might be with other configurations.
But and not to mention, I mean, right now you get on a commercial airplane and you're staring at a screen in the seat in front of you. So instead of a
Right.
window, you give someone a screen.
Yeah, you give them a screen, and so that sort of gets away from the window argument. I mean, one could argue that there are other large airplanes that also are fairly wide, and
Yeah.
not everybody has a window either. Um, so anyway, that from a passenger point of view, that's one of the things that we get. Some of that's been worked out already. We
Hmm.
we feel like that there are advantages to this wide, roomy interior that would come with a blend wing body because of its volumetric efficiency.
So I've also
Go
heard the
ahead.
concern, from a passenger standpoint, I've also heard the concern that when the airplane turns, if it's a large internal structure, if you're sitting on near one wing and you look down and you see all the people next to the other, at the tip of the other wing, way below you. I've heard that criticism, and that also seems to be a bit specious to me. I think I could
Yeah, that's
solve that
good.
one easily.
That's the second one I was going to go to
Yeah.
Mark, and basically what has happened there is people say, well, it looks like you're sitting in the wing. Well, you're not really sitting in the wing. There's a defined space for the passenger cabin. It's it's wider as we pointed out because of the nature of the design. Um, the seat um, locations have been studied and they've been compared to other large airplanes like the 747. And the worst seat on the 47 is about the same as the worst seat on the blended wing body. So there's essentially no difference uh, with the blended wing body as compared to airplanes of a similar size and passenger class.
Yeah. And having often flown in that very worst seat on the 747, I, I
Well,
can testify to that. It's survivable.
no, as
Yeah.
government guys, we always get the worst seat, right?
Yeah. Yeah. Exactly. Exactly. So in terms of cargo, now if we think about it as a cargo plane. So
Yeah.
I've heard folks complain. Well, it would change the way you would handle cargo because you're no longer sliding something into a tube. So but that could be turned to an advantage, couldn't it?
Well, the I won't mention them, but cargo carriers have studied the blended wing body, and in some cases, it the system as designed fits well with their mode of operation. In other cases, there are some challenges and some modifications would have to be made for those cargo carriers that we've looked at. There's one all for it, fits right in. There's another that sees some operational challenges. As far as passengers go, though, all of the designs that we've looked at fit right into the to the 80-meter box. They fit into the gate structure, so there are no compatibility issues with on the passenger side. And as I mentioned, on the cargo side, it's a mixed bag. So in some cases it works well, and in some cases the operations would have to be a little different. But generally speaking, I think it should be said that in all cases, the thing that carriers and operators like is that 15 to 25 to 30% improvement in fuel burn.
Yeah,
So that's
absolutely.
going to be hard to beat with any other technology.
Yeah, absolutely, absolutely. Hey, I'd like to switch gears a little bit because at the
Yeah,
beginning of the program I mentioned this great relationship between NASA Aeronautics and the Air Force. Um, I think it's one of the great untold stories that the American taxpayer should know about. That you've got two agencies in the federal government that are leveraging their resources together. Could you tell us a little bit about that relationship and how your work at NASA interfaces with the Air Force?
yeah, I can. And we recognized probably in the 2005 or 2006 timeframe that there were some issues in in the interactions between the two agencies, and there were a handful of us that decided just to take those issues on, and a lot of it had to do with communications and stepping on each other's toes and not understanding what we were doing, and that things, investments we were making, things we could do to leverage each other's research. And so a number of things were done. You mentioned a working group or a steering committee. Several of us got involved in that. I was one of them, and Rich Welsian was another. Rich Walls is now taking that leadership role for NASA on that working group. But the point is on both sides we recognize the challenges, and we stepped forward and said let's start working that out so the communication is better. Uh, the overlap was reduced in terms of the work we were doing. The sharing of results increased, and the collaboration has just blossomed over the last 15 years through that constant interaction. And so, just to talk more personally about it, when this effort came along, um, and it's kind of been in the making for 4 or 5 years. So, Mr. Guerrero, who's sort of the champion of the effort in operational energy
In
and
the Air
inside the
Force, yeah.
Pentagon,
Yep.
and his support person Dan Pike reached out to NASA and started talking to us about what's the state of blended wing body research? Is that a viable platform? How are you guys doing in terms of maturing the technology? And they were doing a whole lot of homework by interfacing with us and getting those lessons on paper, and then began the very difficult work of selling the program, and selling in quotes, right? It's advocacy,
Yes. Right.
advocacy for the project that we're now working. And once it became apparent that that was going to be a project, I was asked to join in and help them out as a subject matter expert, and they've included me in many interactions as the advocacy continues. And so for me, it's a dream come true. I mean, it's something I've worked on since 2005, and I couldn't ask for a better assignment right now.
Yeah. No, that sounds that's a great story, as I said, and I would always point to the fact that when NASA was first stood up, in part support to national security was in its mission, and there has been that rich history of interaction between the Department of Defense and NASA. The first astronauts flew on DoD missiles. Many of the astronauts themselves came out of the DoD, but the relationship is even deeper than that. And this is a perfect example of leveraging the best technical abilities of the department of the agency, um, for the benefit of national security and the taxpayer. So, I said
Yeah, I agree,
it's a really great story.
I agree. And the nice thing about this project is, um, the language that came with the funding in and the project itself seeks to, and I'll botch this up a little bit, so it's not an exact quote, but it seeks to stimulate the broad adoption of the blended wing body technology in the commercial sector as well as the military sector. So it is that once and for all push to build a demonstrator and prove once and for all that aerodynamic efficiency that all these various customers are clamoring for.
Yeah, and of course, it builds on that rich history of sharing technology between the military and the civilian sector in aerospace. Um, so again,
Exactly.
Dr. Fay Collier, our time is up, but with so many of these podcasts, I have so many more questions and so many more topics, but unfortunately, time does not allow for that. But thank you so much first for joining us on this podcast. Thank you for what you're doing on behalf of the nation, and especially your support for this important mission for the Department of Defense. Um, Again, it's a great technical story. It's a great government story. It's a great personal story. So we appreciate all that you've done.
Thank you, Mark. It was a real pleasure being here today.